Hello guys, in this video I would like to explain about Standardized Precipitation Evapotranspiration Index SPEI. Uh, we know that drought is one of the natural hazards which occur due to the lack of precipitation, and you can say the lack of water enough. The main source of is up. If there is less precipitation, and then we can say there is drought for a long time, and if the precipitation is as there is no or less precipitation for a long time, there can be chances of droughts in that region. And if suppose the temperature is also high, then there is high rate of evaporation of the water, and that's also, create droughts. There are various drought indices which can be used to analyze and monitor droughts. For example, standardized precipitation index, which is one of the most used standardized precipitation index we can use for drought analysis and monitoring. However, there are some limitations, and to cover those limitations, scientists propose other drought indices like standardized precipitation evapotranspiration index SPEI in 2010. In this video, I would like to say some theoretical background. Then I would like to discuss about the detail that how we can calculate and how we can standardize it. So this video is limited to the theoretical details, and the next videos I would like to implement standardized precipitation evapotranspiration index in R and Python. This video is important because if you implement SPEI in R and Python and you have the results, but if you don't know the theoretical background, the concept behind this index, then you will be unable to interpret your result properly. So this is important to know this video, to know about the theoretical background, the concept of SPEI, and then jump into the implementation of SPEI in R and Python, or maybe in the other software. Normally we work like this. We have some strong theory first, understanding of the theoretical background, the concepts, the calculations, and then we have implementation. This can help in interpreting the results of that particular concept, or you can say like this drought index. Okay, let's jump into the theoretical background and the concept, how we can calculate this drought index. Okay, the theory behind SPEI. The SPEI is a multiscalar drought index. I will explain multiscalar separately, so just wait for this. That combines precipitation and potential evapotranspiration (PET) to assist the climatic water balance and detect meteorological droughts. So you can see that this can just use two data sets like precipitation and potential evapotranspiration (PET), which is indirectly the temperature data. We can calculate this from temperature data, and then determine the climatic water balance. You will see what is meant by this climatic water balance in the next slide. To detect meteorological droughts, there are various types of droughts like meteorological droughts, hydrological droughts, agricultural droughts, and socioeconomic droughts. I will have a separate video on each of them, maybe later. Okay, this index was proposed by Precipitation in the paper in 2010 to overcome limitations of the SPEI, standardized precipitation index, which only considered precipitation. So the SPEI consider only precipitation. Therefore, this guy with the other their team proposed this index, which overcome obviously the limitation of SPEI, because that SPEI use only precipitation data, but SPEI use precipitation data as well as temperature data indirectly, because evapotranspiration, potential evapotranspiration is calculated from temperature data. Now, conceptual basis of this SPEI. The basic input to SPEI is climatic water balance. The basic input, yes, okay. So this is now climatic water balance. The difference between these two variables, that is DI, the difference per ith month. Normally we have monthly data, so difference per ith month is equal to precipitation in the ith month minus PET in the ith month. So this is climatic water balance. Remember that this is not SPEI now. This is only climatic water difference with I denote by D, and for I mean for ith month. DI water balance for month I, precipitation for month I, PI mean precipitation for month I, PETI is potential evapotranspiration for month I, which is typically estimated using Thwaites or Penman methods. There are various methods. Two are mentioned here. You can use any of those methods. However, you need to see which method is better. You can use any one of them to calculate potential evapotranspiration. I would like to have a separate video maybe later, not now, on these method as well. This water balance is then aggregated over the chosen time scale. So now once you have this difference, you can aggregate over the time scale, maybe for 1 month, or for 3 months, for 6 months, for 9 months, for 12 months, for 24 months, on maybe for 48 months, depending on the type of drought you want to study, agriculture versus hydrological. So this is, they can have different durations. So if you are interested in any type of droughts, you need to see which time scale is appropriate for which drought, and then you can use that time scale. Like suppose you are interested in 3 months drought assessment and analysis and monitoring, you need to aggregate this DI, this water balance, for 3 months. Okay. A probability distribution fitting. So what, maybe you can be astonishing why we are using probability distribution here. This is very important to use probability distribution here. Remember that you have DI now is the variable with you. Now you don't need this PI and PETI. You have DI, and you need to fit the probability distribution because maybe standardization, which we have later. This is here, so you will see in there in standardization. I will explain why you need probability distribution. The aggregator water balance series is then fitted to a probability distribution. Remember, the aggregated mean you are calculating for 1 month, for 3 months, or something like that. You aggregate DI for those whatever the required months as. You need to fit a probability distribution to that series. There are various distribution you can use, like log normal distribution, like gamma distribution, like log logistic distribution, maybe other as well. The SPEI developer proposed the log logistic distribution because it is flexible and better fit for D series. D series mean this data which we have in this slide, DI. Okay, the subscript I is not mentioned, but this is the same D data. Okay, this one from here, this one. Okay, so the developer of the SPEI proposed that log logistic distribution fit better the D data, the difference data, the water balance data. But I suggest you can use other distribution as well, like log normal distribution, log normal distribution, gamma distribution, log logistic distribution, maybe other distribution as well. And then you see which distribution fit better your data. You can use goodness of fit test to see which distribution better fit your data, and then you can choose which the distribution which better fit the data. But the developer suggests you can use log logistic distribution, and the reasons are log logistic distribution because it's flexibility and better fit for these series. So maybe when you try other distribution as well, you will see log logistic is better. That can be the case. The probability density function of the log logistic distribution is, so this is the probability distribution of log logistic distribution, that FDI, this is just like, we denote f of xi, so this is di because di is the data now with us. This is di series here, and that is alpha by beta, so the parameter, and d minus, you can write di as well, that is mentioned here, d minus gamma divided by beta power alpha minus 1 n to 1 plus and in bracket d minus gamma divided by beta for alpha and whole power minus 2. This is the probability density function of log logistic distribution, where d is greater than gamma, and where alpha, beta are greater than 0, and gamma is origin or threshold parameter which need to be estimated to calculate the mean and standard deviation essential for standardizing DI. Remember that we need to standardize DI, and remember that this is now the variable. So you need the mean of DI and you need the standard deviation of DI, then you can standardize. So standardize mean that, like suppose we have D variable, so the standardized variable we denote normally by Z. For Z, for normalizing D, we will say, okay, Z is equal to DI minus mean of DI divided by standard deviation of DI, like just like the other standardization. So you need the mean and standard deviation of this distribution. Therefore, we need this distribution. You need the mean of DI and standard deviation of DI, but for that purpose, we need to find the appropriate distribution. So if suppose this is your appropriate distribution, then you need to estimate the parameter. To fit the model, we need to estimate the parameter from the data. So once you have this parameter, you can calculate the mean and variance. I don't have that expression now for the mean value and standard deviation, but of course these parameters are used to calculate the mean and standard deviation of DI. So once you have the mean and standard deviation of DI, I mean for this distribution, then you can standardize DI, and that standardized DI we call SPEI. That means standardized precipitation or transpiration index. So now let's come to standardization, and you know that why we need that distribution in the step 2. Once the distribution is fitted, distribution fitted means to find the parameter, to estimate the parameter from the data. The cumulative probability is transformed into standard normal distribution. Mean is equal to 0 and standard deviation equal to 1. So that's mean when you transform the distribution, transform the variable D or DI into another variable which we normally call standard normal variable, that is mean Z, like we denote that by Z. The mean of standard normal distribution is mean equal to 0 and standard deviation is equal to 1. Remember, this gives the SPEI value. So once you standardize this gives you now SPEI, that is now standardized precipitation or transpiration index. Remember, standardized mean we have make this procedure of subtracting the mean from DI and divided by standard deviation. So that is standardization. Precipitation, you are using precipitation data and evapotranspiration data. So precipitation and evapotranspiration, these are the data set you are using. Index. So you are using, so this is the meaning of the name as well. This is explained clearly. So this process, the process of standardization, ensure that SPEI values can be interpreted similarly to a Z-score, enabling direct comparison across time and region. So this is just like Z-score. Now it is standardized. You can compare with different time and region. That's it. Universally you can compare these values now. So this is one of the advantages. Multiscalar nature, yes, I left this question in the first slide, so I will like to explain it now. SPEI is a multiscalar, meaning it can be computed over various time windows. So this can be computed for 1 month, 3 months, 6 months, 9 months, 12 months, 24 months, 48 months, and so on. You can use, for depend in which route you are interested. 1 month short-term meteorological routes, 3 to 6 month agricultural route, 12+ month hydrological routes. So you can use for 24, that can be hydrological routes, and for 48 months, that can be also hydrological routes. Each time scale highlight different impacts depending on the temporal behavior of the water deficits. Yes, so that's different when you calculate the values of this index. Now this is some comparison. In the first slide we say, okay, this overcome SPEI overcome the limitation of SPI. So let's see what are the differences and what are the plus and negative point of each of them. Use only PI. So SPI use only P data, that is precipitation data, and this is not using this data because this also use temperature data. Consider PET. Okay, so this SPEI using PET, which is indirectly the use of temperature data, because PET we calculate from temperature data, and this SPEI does not use PET. Climate change sensitive is not to climate change sensitive, and this is to climate change sensitive SPEI. Multiscalar, both are multiscalar. Easy interpretation, both can be easily interpreted. So this is some of the plus point and negative point of each of them, and you can see SPEI has higher number of positive points. This is the reference, this is the guy and the team who proposed this index, which I mentioned in the first slide in 2010. So if you are interested, you can just look at this paper and copy this link. Just mention this link in your browser, and you will see this paper, and you can see the detail which you have presented in this video. So what we have learned? We have learned about standardized precipitation index, SPEI, which is one of the most popular drought index and can be used for analysis and monitoring droughts. We have learned about the theoretical background briefly, and then we have calculated the concepts, the calculation, the standardization, and then at the end we saw some differences between SPI and SPEI, that which model has more strong point. So I think this is enough for today, and I would like to have more videos about the implementation, the analysis, and the prediction, maybe about the drought analysis and monitoring using SPI and R and Python in the future. So thank you very much, and see you in the next video. Ciao.